Question number 6. You want to do a Turkey's honesty significant difference HSD post hoc test. What is the Q value? Okay. What HSD test is about, when you what I'm trying to do here is to there are 3 groups, right? And we wanted to compare the mean differences between, for example, these 2 and these 2 and these 2. So in this example, I wanted to compare the differences between this and this, this and this, and this and this. And actually, there's a better way to this and this, this and this, or this and this. We're gonna compare mean differences and decide which mean differences are statistically significant. Because we rejected null hypothesis, stating that there was some difference somewhere, and we'd like to find out where the differences were. So we're going to compare these 3 differences and figure out which differences are actually statistically significant. Yeah, so let's do this calculation. Okay, let's compare group 1 and group 2. 2.33 minus 2.82, and what is that? That is minus 0.49, right? And okay, let's compare group 2 and group 3. So 2.82 minus 3.53 is minus wait a sec, 531871, right? Minus 0.71. And I want to compare group 1 and group 2, so let's compare the mean difference. Let's calculate the mean difference. 2.33 minus 3.53, which would be again minus 1.0, looks larger than the other 2. Okay. So now I know mean differences between group 1 and group 2, group 2 and group 3, and group 1 and group 3. So which mean differences are actually statistically significant? That's what we're trying to figure out with this HSD test. Well, from at a glance, I would say these these 2, but not sure yet. Maybe only the last one. We're not sure yet. So how you do that? We do it by coming up with this value, HSD value. HSD value is like it's a standardized value for for mean differences, and when so we get this value HSD, and if these differences are larger than HSD, then we conclude, which basically, so what we're trying to do is find out whether these values are larger than HSD or not. If they are larger than HSD, then they are statistically significant. That's what we're trying to do. So how do you calculate HSD? HSD is calculated by this formula. Okay. So Q, let's see, HSD Q mean square within divided by n. When you say n, it's not the capital N, so it's not the total number of scores in the whole three groups together. In this case, each group has only 5 scores, so whichever group you take in the number from, it doesn't matter. But sometimes, group 1, group 2, group 3 might have different numbers of scores, samples. Then it's going to be a problem. In that case, just get the smallest number. But in this case, okay, 1, 2, 3, 4, 5. Actually, it's 6. I didn't say 5. I said 5, but it's 6. So this n is just a number of these. So just 5. So that's gonna be 5, right? No, it's 6. And mean of square within, what was that? I think it was like 0 point something. Let's see. Mean of square within was 0.271. Okay, 0.271. It was 0.271. And what is this Q value? This is not 9, it's actually Q, OPQR. So Q, huh? How do you get the Q value? This is how you get Q value here. Okay, here it is. There's a Q table. Use a Q table and get the Q value. Degree of freedom is going to be one of the factors. I have a Q table here, so I'm gonna open it. Okay, now I got the Q table. Q table, and the degree of freedom within was 15, so it's here. And we are using the 0.05 alpha level, so we're going to use a lighter font, lighter face type. And in this case, it's not the degree of freedom within between. Actually, this is just a number of groups. So we take the number 315. So 3.67. 3.67. Okay. So Q is 3.67. 3.67 times 0.271. Okay, which is 3.67 times 0.045. Well, that's probably enough. And get that square root. Get the square root of that is 0.212. Okay, so seven times 0.212. Okay, which is 0.779, so 0.78. 0.78. That's the HSD. The value of the HSD. That's 0.78. You know, I don't exactly know the distribution shape. I don't exactly know at all. It may be like this, I don't know. I don't exactly know, but anyway, critical value is 0.78. Well, I don't know if that's the way to interpret this. I don't think so. But anyway, so this is the HSD value, and any mean differences larger than this would be, you know, statistically significant. So we have three different mean differences here, and based on this number, I would have to say, you know, it's a distance between two, you know, so I have minus, minus, minus. You know, you don't have to, you just ignore that because it's just the directions. And here, only thing because we subtracted this way, you know, if I switched around the numbers, then they all could have been positive, and it doesn't really matter if positive or negative, because what we are concerned about is the distance between these two. So basically, you know, it's like a zetaichi. You know, so it's what I'm concerned about is the 0.49, just absolute, you know, distance. 0.71, 1.2. You know, these three numbers, and okay, from this, only this is larger than this. So I would have to conclude that only this mean difference, which was the mean difference between group 1 and group 3, that was the only mean difference that was large enough in this scenario. Question number 8: which mean differences are statistically significant? That's what I just did. So that's what I did here. Question number 7: what is the HSD? This is the HSD. Okay, so that's the HSD value. And what is the Q value? Q value was this. I used a Q table, you know, with the number of groups and the degree of freedom within. Okay, so that's all. That's it for this week.